what will be this? We have done the properties, na simple properties we have done. So let us write oxy acids of oxy acids. Oh, wait a second. This will be second in chemical properties, right? We have done the hydrides. This will be second in chemical properties, oxy acids of halogen. Oxy acids of halogen. Okay. So now write with me. Halogens form. Halogens form. Where is that girl, Mariam? She has to do the group 18, na? Can somebody please text her? Halogens form four classes of oxy acids. Four classes of oxy acids. What are those four classes? Okay, Abir is here. The first one is, write with me, hypohalous. Hypohalous acid. Hypohalous acid will have a general formula HXO. This X here can be, in which this X can be fluorine, chlorine, bromine, fluorine, chlorine, bromine, iodine, and not astatine. So good afternoon, Abir. Now second one, B would be halous acid. Now, for example, if you have a hypohalous acid of fluorine, it will be called hypochlorous acid. Sorry, hypofluorous acid. For chlorine, it will be hypochlorous. For bromine, it will be hypobromous. For iodine, it will be hypoiodous acid. Okay, now halous acid. This halous acid has a general formula which is HXO2. Now here, the X can be either chlorine, bromine, or iodine, but not fluorine. The reason, we will write the reason later. Okay, A, B, C. Now here you have halic acid. Here we have halic acid. Now in halic acid, the formula is HXO3. You will have X equal to chlorine, bromine, or iodine. And the last one, that is D, perhalic acid. Perhalic acid. In this you will have HXO4. Here also, the X can be either chlorine, bromine, and iodine. If you look at the NCERT textbook, they will say that, see, the fluorine analogous of halous, halic, and perhalic cannot be made. Let us first of all write the reason for that. Okay, so write a remark or note here. What would be the remark? Remark would be fluorine only forms please write these things with me. For fluorine only forms one oxy acid. Why does it form only one oxy acid? Because due to of smaller size, due to smaller size and high electronegativity. Okay, since here it cannot accommodate two oxygen and one hydrogen, this little fluorine guy, it cannot, the fluorine, it is of very small size, it cannot accommodate two oxygen and one hydrogen, or and if it cannot accommodate two oxygen and one hydrogen, I mean there is no question of asking whether it can accommodate 3 or 4 oxygens, right? So that is why it only forms hypohalous due to low size, that is small size, and high electronegativity. They would also ask oxidation state. Oxidation state of fluorine in HFO. Right? This is what? This is hypofluorous acid. So the structure looks something like this: fluorine, oxygen, and here you will have H. So they can ask for both of them, for fluorine also and for oxygen also. Okay, so let us find that fluorine and oxygen. Now please see, we have this bond, that is oxygen and fluorine bond. In oxygen and fluorine bond, if we check the electronegativity, then we can say that fluorine is more electronegative. That is why for this bond, the oxidation state for fluorine will be -1, oxidation state for oxygen will be +1. Now if we compare the electronegativity of the OH bond, then Abir, tell me, between oxygen and hydrogen, which is more electronegative? Oxygen and hydrogen, if we compare, which is more electronegative? Yes, Abir. In oxygen and hydrogen, which is more electronegative?
Sir, oxygen.
Oxygen is more electronegative, right? So if oxygen is more electronegative, we will give -1 to oxygen for this bond and +1 to hydrogen for this bond. Now if we look at the oxidation state of oxygen, it is equal to what? Fluorine is -1. Yeah, oxygen is 0. So this is important. The oxidation state of oxygen in hypofluorous acid is 0. Raise your hand if you are done. Amalia, did you message Mariam?
Yes, sir.
Okay, thank you.
Sir, today's class you started with this one, the oxyacids of halogens.
Yes, yeah. We didn't do anything else.
Okay, sir.
Be waiting for Abir, Nazira, and Sanya. Please raise your hand if you are done. Okay. Waiting for Abir now. Okay, everyone is done. Let me just lower your guys' hands and we can start now. Structure of, okay, structure of oxoacids. Structure. So first of all, we will look at the structure of hypohalous, right? Structure of hypohalous. Hypohalous is what formula? It is HXO. HXO. You just have to make X and then OH. So the number of OH bond is equal to the number of hydrogen atoms. The number of OH bond is equal to the number of hydrogen atoms, right? And then with HXO.
Yes, sir.
The next one is what? After halous, what do we have? After halous, what is the next one? Halous.
Halic.
Oh, sorry, this was hypohalous, so this is now halous, right?
Yes, sir.
Let me write both the things. Hypohalous, HXO. Now we will deal about halous, which will be HXO2.
O2.
Correct?
Yes.
Now in this, you have to make the number of OH bonds. First of all, make the OH bonds. So this will be X, OX, and oxygen. What is the oxygen? I mean, what is the covalency of oxygen? Normally, it makes double bond because it is at terminal. Okay. So this X has made how many bonds? 3 bonds. It has 2 lone pairs now. It has 2 lone pairs now. Okay. Now in this structure, it has 1, 2, 3, 4. Right. It has 7 valence electron. 1 electron is in bonding with oxygen, and then we have the 6 valence electron as lone pair. Here we have 3 valence electron as the bonding pair, and the rest 4 are as lone pair electrons. After halous, we have halic. Halic acid. What is with the formula? It is HXO3. So again, X, then you will have one OH bond, then you will have a double bond oxygen, and one more double bond oxygen. Now in this case, we are using 1, 2, 3, 4, 5 valence electron of X in bonding. So we will have one more electron pair which will be in lone pair. The last one is, what is the last one? Perhalic. Perhalic acid. Perhalic acid has the formula HXO4. Here you will have again X, then you will have OH bond, double bond oxygen, double bond oxygen, double bond oxygen. Here we are using all the 7 electron pairs 1, 2, 3, 4, 5, 6, and 7. So there are no lone pairs. Okay, there are no lone pairs. Okay, is everyone done?
Yes.
Also, see, you can say that in hypohalous, what is the oxidation state? Except what is the oxidation state? Except fluorine, all will have +1.
Yes,
Right?
sir.
Except fluorine, all will have +1. Now here the oxidation state will be +3. Okay. Here the oxidation state will be +5. Here the oxidation state will be +7. Okay. In the first one, please remember that it is +1 except for fluorine. For fluorine, it is -1. Okay, please write the order also. I mean, we have stated regarding the order, so please. This order is not in the syllabus, but we don't know. HClO4, and we have HClO3, HClO2, HCl. Oh, now in this case, it is +7. This is +5. This is +3. This is +1. So obviously, the more oxidation state, the acidic strength will be higher. Correct? The acidic strength will be higher, right? Now, for example, if you have, complete this first. Here you have different oxidation state, okay? But for example, if you have same oxidation state, if we compare between HClO4 and HBrO4 and HiO4, this will inversely depend on the size. So HClO4 is smallest, so it will have most acidic strength. Right, those two. Oxidation
Yes, sir.
state is directly proportional to acidic strength, and acidic strength is proportional to size of atom. Now, these two cases are only for oxy acids. These are only for oxy acids. Okay. Are you guys done? Let me know if you're done.
Yes, sir.
Yeah. What about others? Is everyone done, or is someone writing?
Sir,
Done.
writing.
I guess you are writing. Okay, fine. Write it. For halogens, you just have structures only in your syllabus. It is explicitly written oxy acids of halogens, structure only. But you
Yes,
can
sir,
also
done.
remember this. Okay, done. Fine.
Yes, sir.
Okay. Now, right, this is important. Inter-halogen compounds. Inter-halogen compounds. Now, what are inter-halogen compounds? First, write the definition with me. Then I will explain different things about the inter-halogen compounds. Okay. So these are covalent compounds. These are covalent compounds formed by the combination of two different halogens. Covalent compounds formed by the combination of two different halogens are called Inter-Halogen compounds. Are called as inter-halogen compounds. Now, if you are done, please stop writing and start listening. Types of inter-halogen compounds. Please don't write these things. Till here you can write. Don't write any further. Types of inter-halogen compound. Okay. The type of inter-halogen compounds, you will have X dash. Okay. There are few types that you can make. There are 4 that you have to study. The first one of them is X dash. What is this X? This is X and a halogen. This is another halogen. You can either make X dash 3. You can make X dash 5, and you can also make X dash 7. Okay. Now, what are the compounds that you can make if you have this X and X dash? You can make, see, in all of these cases, the X dash should be more electronegative. This X dash should be more electronegative. Okay. Now, Ahmed, you will tell me in fluorine, chlorine, bromine, and iodine, which is the least electronegative?
Iodine.
Iodine is the least electronegative. So we will start from there. Okay. So just listen now. If you have iodine, then iodine can make IBr, it can make ICl, it can make IF, right? Right. And now it is what? Completed. For iodine, we are complete. Now we will look for bromine. So BRI, it cannot make BRI. It will be BrCl. Okay, it will be BrF, right?
Yes, sir.
It will be BrF, and after that it will be, you will have Cl.
Yes, sir.
Yes, CLS. Now in X and X dash 3, you will start with IBr3. Then you can make ICl3. Please don't write. Nobody will write. Then you will make IF3. Then you can make BrCl3, BrF3. You can also make ClF3. Now please remember, in these compounds you cannot make IBr3 and BrCl3. Why? Because see, iodine is in which period? Second, this is third, this is fourth, this is fifth period. Now this is fifth period atom, and it is, you want to have 3 bromines, so it is difficult to accommodate 3 bromine atoms around 1 iodine. Okay, and similarly, it is difficult to accommodate 3 chlorine atoms in 1 bromine. That is why IBr3 and BrCl3 are not formed. Okay, now in the next case, while you are having X and X5, if iodine cannot accommodate 3 bromines, the question of 5 bromine cannot be asked, right? So obviously
Yes.
it cannot accommodate 5 bromines also. So we will directly start from where? IF5.
ICl.
Okay. Now ICl5 is also, it cannot even make ICl5, because again you can see it's 5 chlorine atoms around the iodine. Okay, so it does, only iodine has IF5, then you have ClF5, then you will have BrF5. Okay, now in the 7th one, there is only one molecule, that is
7.
IF7. Okay, only IF7. So please write these things. Also, just have a pattern, and after that cross these two, IBr3 and BrCl3. Raise your hand if you are done, okay? Okay, Ahmad is done. Assalamu alaikum, Mariam. Are you fine?
Yes, sir. Alaikum assalam.
Okay, what Namra? Namra, are you here for P block elements, class 12th?
No, sir.
Then, you're for which class?
Physics class, laws of motion.
Laws of motion physics class? I don't think so. This is the link. Please contact Nishkar sir.
Okay, sir.
Okay, thank you. So, why are you late, Mariam?
I was sleeping.
वेरी गुड, वेरी गुड। अल्लाह कर, मतलब काश ऐसा हो जाता कि ग्रुप 18 खत्म हो जाता तब आप उठते तो मजा ही आ जाता। ओके, एवरीवन इज डन एक्सेप्ट मरियम। अबीर, आर यू डन?
Yes, sir, done.
ओके, फाइन। नाउ लेट अस स्टार्ट स्ट्रक्चर्स। ओके,
Sir,
structures
is
of
CLF5 possible?
yes,
How?
what is possible?
CLF5?
I mean it exists, that is why it is possible. There are experimental proofs for that.
But sir, there are 5 fluorine, around 1 chlorine atom.
I mean ये तो फिर आप खुदा से सवाल कीजिए कि कैसे बना दिया इसने। But it exists. So most of the times, you, as I have said, now you will have experimental evidence, and you cannot deny those experimental evidences if it exists. If it exists, then it exists. Now, why somebody does not exist, then we can explain that it does not exist because, okay, fine, chlorine has larger size than Br. I mean, 3 chlorine will have larger size than 1 Br. Okay.
Yes, sir.
Next is structures. Now in structure, you will have the first one, that is XX dash. This all will be linear, right? There are only, I mean, you don't have any option here. There is only one structure that is possible, that is linear, correct? Now second, you have X dash 3. Now for this, I am taking the example of, let us take BRF3. Okay, we are taking the example of BRF3. Now all of the other compounds, even if I take ICl3, IF3, BRF3 or CLF3, all will have the same structure because the valence electrons are same. And if the valence electrons are same, that means they will follow the same Vesper theories, right? So bromine has how many valence electron? How many valence electron does bromine have? 7, right?
Yes.
Okay, so 7. Now in those 7, there are 3 bonding pairs, and you have 3 bonding pairs plus you will have 4 electrons more. That is why 2 lone pair electrons. So this will give you 5. Now if the steric number is 5, what is the structure? Or what is the geometry? Tell me the geometry. If the steric number is 5, what will be the geometry? 11 standard questions. 11 standard.
3D.
Trigonal bipyramidal.
Nobody.
T.
Trigonal bipyramidal. Correct.
3D.
TVP, correct. Trigonal bipyramidal. 1, 2, 3. Then you will have one above and one below. Now, where do we put the lone pair electrons? In the axial or the equatorial ones?
Equatorial.
Yes, correct. Equatorial ones. We put the lone pairs on equatorial ones. So we have put the lone pairs on equatorial ones. And you will put the fluorine, chlorine, and fluorine. Now, as you can see that this lone pairs can exert some kind of repulsion here, and they can make this fluorine, they can bend these fluorine like this. Okay. So this is what you call as bent T shape. Okay, this is bent T shape. Is that fine? Now,
Yes.
if you try this for even IF3 or ICL3, we will get the same kind of structure. Okay. So even if you write the T shape, it is fine. If you write the bent T shape and draw this thing and with the repulsion here, then also it is fine. Now, next thing is what? X-5. X-5. Now, when you have X-5, this, let us take the example of BRF5. Now, in BRF5, we have how many lone pairs? We have 5 bonding pairs plus 2 lone pairs, which is equal to how much?
Lone pair.
Sorry, 1 lone pair, which is equal to 6. That is why it will be octahedral. Right? It will be octahedral. Now you have bromine 1, 2, 3, 4, 5, 6. Now in this you can make lone pair, you can put anywhere because all of these are equivalent. Fluorine, 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 and fluorine. So as you can see, this is in one plane. Now you can make a pyramid like this. So this is what? Square pyramidal. This is square pyramidal, okay? Complete this slide now. Let me know if you are done.
Yes, sir.
Okay, what about others? Is everyone done? Should I move on? If somebody is not done, please let me know. Everyone is done, I guess. Please say no, sir, if you are not done. Okay, everyone is done. Now the last one, that is X-7. So you must not have heard about this type of geometry. X-7. This is IF7. Now here you have 7 bond pairs
Plus
plus 0 lone pairs. This is equal to 7. Now for 7, you will have here pentagonal bipyramidal. So what? Pentagonal bipyramidal. So you will have iodine, and this iodine you will have 5 fluorines like this. Fluorine, fluorine, fluorine. Like this, 5 fluorines. Okay, so this is pentagon, and then you can put one above it and one below it. Okay, 2 more fluorines like this. Fluorine, then the other fluorine. So this is pentagonal bipyramidal. Can I write this down?
Yes, sir.
Okay, everyone done? If somebody is not done, please let me know.
No,
I
sir.
will move on. Okay. Don't raise hand, Sanya. Sonia, don't raise hand. Small slide now. Should I move on?
Yes, sir.
Yes, sir.
Okay. Now next you have method of preparation. So in the method of preparation, you won't have much points. The points like this, they can be direct, they can be prepared. By direct combination of, please write this with me. By direct combination of halogens. Okay. Controlling the product is difficult. Okay. For example, you can make X dash products very easily. What you have to do, for example, you have to make ClF. So you will have Cl2 plus F2, and you will take this in equal volume or equal, I mean in equal concentration, you will get 2 ClF. Okay. But if you have, for example, I2 plus Cl2, if the Cl2 is in excess, so you can either make ICl3 or even ICl5. Okay, so this type of controlling is a bit difficult. Okay, for example, but if you are given something like, now if you have, you will write it like this and like this. Now if you are given something like this, Br2 plus 3F2, what will you make? Now this is very easy because they have given you the stoichiometry here, so you can play with the stoichiometry and write 2Br F3, correct? Now if they have given you Br2 plus 5F2, now again they have given you stoichiometry, so you can easily write 2Br F5, correct? So when the stoichiometry is given, it is not very difficult, you can easily make this product. While you are writing the method of preparation, just in the next line, we will write some remarks. Okay, please write this with me, there is nothing to explain here. Okay, the first thing is that these all are covalent in nature. All are covalent in nature. Second point is that all are diamagnetic. All are diamagnetic. Now the third one is inter-halogen compound. Inter-halogen compounds are more reactive than its corresponding XX. What does XX means? Than its corresponding parent halogen molecule. Than its corresponding parent halogen molecule XX. Except fluorine F2. Now fluorine, as you have seen that there are interelectronic repulsion, and that is why they can easily dissociate. So F2 is more reactive, but except F2, every other interhalogen compound is more reactive than its corresponding XX. As the XX dash bonds are weaker than XX bonds. Okay, but the only exception here is fluorine, and there is a reason for that exception, that is the interelectronic repulsion. Okay, so for example, if you have to compare the order, so the order of reactivity will be fluorine is the most reactive, then you have I dot H. What is this? I dot H dot C. This is interhalogen compounds, and after interhalogen compounds you will have, what will you have after this? Bodo bhai. After inter-halogen compounds, which will be more reactive between Cl2, Br2 and I2?
Cl2. No, I2.
Why I2? Or why
Because
Cl2?
I2 because it's like the size is big and it will easily go under any reaction.
Okay.
It can go under any reaction easily.
Because it is big.
Yeah, it will lose its
But
right.
can you see that it is making the bond with the same type of iodine, na?
Yeah, still
Still it will be
react
pure.
easily.
See, now you tell me I2 is solid, okay? Br2 is liquid, Cl2 is gas, which will be more reactive.
Yes.
Gas will be more reactive, na?
Yeah.
So Cl2, then Br2, then I2.
Excellent.
Complete the slide. Now, as we have all seen in all of these inter-halogen compounds, there is X and there is X dash. This is what? This is less electronegative. This is more electronegative. Okay. Now remember this. This will help you in the products of hydrolysis. When we will do the hydrolysis of inter-halogen compounds, it will be helpful. Okay. Ahmed is done. Abir is done. Okay. Is anyone left? Is anyone writing? Should I move on? Okay. Somebody is writing. Please let me know. Otherwise, I can move on. Yeah. Hydrolysis. Next point is hydrolysis. Now, please listen. Don't write. Hydrolysis. Now, when you have inter-halogen compounds, that is IHC. Okay, we are writing it short as inter-halogen compound plus water. Okay, this will give you two products. You will get a halogen acid, the hydra acid. For example, HCl, HF, HI, these type of things. Okay, plus you will get an oxy acid. You will get an oxy acid of halogen. Now, this halogen acid will be of the more electronegative element. The oxy acid will be made by the less electronegative element. Okay, is it clear with everyone? Can I get a yes sir from everyone? Abir, Ahmed, Amalia, Fatima, Mariam, Nazra, and Sania?
Yes,
Yes,
sir.
sir.
Yes,
Yes.
sir.
What about girls? Yes. Now I will start asking questions. Okay. Now you have this. Okay. Let me see who all are present. Okay. Now Sania said yes sir. Okay. Ice. Okay, fine. Abir, ICl plus H2O. What will be the product? ICl plus H2O. Tell me the halogen
ICl4.
acid. Abir. Okay, I'm asking Abir.
So you did not say the name first.
I said Abir.
Not at the first.
Sir,
Yes, Abir.
chlorine
What
plus
halogen?
chlorine.
Chlorine? Okay, tell me out of iodine and chlorine, which is more electronegative?
Chlorine.
Chlorine is more electronegative now. So what will be the halogen acid of chlorine? Halogen acid means HCl, right? It is what? It is HCl, okay?
HCl.
Plus, you write HIO plus HIO, okay?
Yes, sir.
Okay, now, second one, please see these things. ClF3 plus H2O. Mariam, what will be the halogen acid here? Mariam, what will be the
Fluorine.
halogen acid? Just tell me the formula.
HF3.
अरे वाह, HF3 कुछ होता है क्या? अरे भाई आप लोग तो गजब ही हो गए हैं. The only halogen acids are what? HF, HCl, HBr
Yeah, HR.
and HI, है ना? इसके अलावा नहीं होगा कुछ halogen acid. ठीक है, it will be HF. Now you have to do the balancing here, right? You have to do the balancing here. So we'll write 3 here. Okay. If you have written 3 here, now here also you will have one H because of how many oxygens are there here? Now you have 3 hydrogens. Here you will do 2. Now you have remaining 2 oxygen atoms. You will write HClO2. See, you have written 3 here. Why? Because there are 3 fluorines. Now here I wrote 1 H because if I make a oxy acid, all of the oxy acid is having how many hydrogens? Only 1 hydrogens. So obviously there will be 1 hydrogen here. So that makes 3 plus 1, 4 hydrogens. That is why how many H2O molecules? 2 H2O molecules. And in this 2 H2O molecules, we will have 2 oxygen atoms. That is why HClO2. That's why HClO2. Okay, next one. Don't worry about the oxy acid. I will be telling you the oxy acid. You just have to identify the halogen acid. That is BrF5. Nazira, what will be the halogen acid here?
5H5 HF
HF. Very good. Now you will write here 5
5H
plus 1 hydrogen here because it is an oxy acid. So here I have to write how much? Here I have to write 3. So this will be H, Br is remaining, and O3. See, it is balanced also. Okay. Next, IBr plus H2O. Okay, Fatima.
HBr
Very good. HBr. Can you
plus
help me in balancing? Plus
H
plus H.
H
Huh?
high O.
I. Oh, very good. Okay. So this is the hydrolysis. Okay. Please write this down. If you have not written, if you have written, just let me know by raising your hand. You need to raise hands now if you have written. Okay, 1 hour is remaining. I don't know. ये यार सैटरडे तक चले जाएगा. तुम लोग तो सवाल ही करने का नहीं, बहुत टाइम लगा देते तुम लोग.
So we have to write this?
Yes. Or your mic is not working, or what? Your earphone is not working. What is happening here?
No, sir, I was
Write this first. Let me know when you are done. So inter-halogen compounds was the third chemical properties. The fourth one will be oxides. The fourth one will be oxides.
Yes, sir.
Okay. Mariam, Sania, Fatima, Ahmed is done. Abir. Sania is also done. Waiting for Abir. Fatima is done. Abir and Mariam. Mariam is done. Waiting for Abir. Yes, Abir, are you done? Still writing? Okay, Abir is done. Oxides. So there is a remark, and there is one point in the remarks of oxide that is important. Other things are not very much of important. Halogen forms, please write this with me. Halogens form many oxides, but most of them are unstable. Most of them are unstable. Okay. Now write all. See, if you have fluorine, there will be some oxides of fluorine, chlorine, bromine, and iodine. Okay. So for fluorine, let us start with fluorine. Fluorine makes OF2 and O2F2. Okay, and these are not oxides. These are not oxides, but fluorides, because here fluorine is having a negative oxidation state. Oxygen is having a positive oxidation state because fluorine is more electronegative. Okay, these are not oxides but fluorides. These are fluorides. Now the next one, they all will be oxides only. Now chlorine, it can make Cl2O, can make ClO2, and it can make also Cl2O6, or you can also write this as ClO3. It dimerizes. Next, Cl2O7. Okay. Bromine also. Bromine can make Br2O. Please write this with me. O3. Okay. Iodine can make something like I2O4, I2O5, I2O7.
Yes, sir.
Done. Okay, fine. Remarks. What will happen in remarks? Remarks first point. See, as the oxidation state increases, whenever you have a cation, if you have sodium, sodium has how many electrons? It has 11 electrons. If you remove one electron, it will be sodium 10. Now imagine there are 11 protons which are attracting 10 electrons. Now the force of attraction will be much high, and it will shrink. So whatever this cation is there, if the cation is present, that means its size will be smaller than the parent one. So if the oxidation state increases, what happens? The size decreases. The size decreases. Now if the size decreases, what happened? If the size decreases, you know that the bonds will be smaller. Now bond energy will increase. Bond energy increases. And if the bond energy also increases, the stability increases. Stability increases. Now here, if you compare between Cl2O, ClO2, and Cl2O6, and you have Cl2O7. Now here, what is the oxidation state of chlorine? It is +1, correct?
1. Yes, sir.
Here it is
+3.
+4 by oxygen. There are two oxygens, no?
Yes, sir. +4.
Here it is +3. Huh? What is the
Yes,
oxidation state here? +3.
+3.
3.
12
2x
minus 2
2x
plus
plus
+6.
minus 12.
minus
It is
12.
+5. Okay, here it was. Wait a second. What is the oxidation state here? X minus 4 is equal to 0. X is equal to +4. Correct? Here it
Yes,
is
sir.
2x minus
12.
12 is equal to 0. So x is equal to
6.
6. Here it is
X is equal to 7.
2x minus 14 is equal to 0. So x is equal to
7.
plus 7. Okay, so the stability order will be like this. Higher the oxidation state, higher will be the stability. This one, this is plus 4, this is plus 6, this is plus 7.
Yes, sir.
Done. Next point, oxides of halogens are reactive and oxidizing agent. Okay, now the oxidizing power, it will depend on the stability, and it will be inversely proportional to the stability. If the stability is high, it will be less reactive. If it is less reactive, that means it will be having less oxidizing power. So oxidizing power is inversely proportional to the stability of oxide. So if we want to put the order here, the order will be Cl2O will be most powerful oxidizing agent. The oxidizing power will be the most for Cl2O, then it will be for Cl O2, then we have Cl2O6, then the most stable one, that is Cl2O7.
Yes, sir.
Okay, is everyone done? Is anyone still writing?
Sir, OP is oxidizing.
Oxidizing power. Yeah, oxidizing power.
So that is the order of what? Oxidizing power.
Yeah, order of oxidizing power. This is for stability, na? This one is for stability. This is OP, oxidizing power. Inversely proportional. Can I move on? Is anyone writing still? Is anyone still writing?
Done.
Done? Okay.
Done, sir.
Now write one point that is important in remarks. Oxides of bromine are least reactive, are least stable, most reactive, are least stable due to middle row anomaly. Look at your textbook and see, RT, this word is present in brackets, okay? Middle row anomaly. Now, if somebody will ask you question about middle row anomaly, people will say that it is out of the syllabus. It is not out of the syllabus, it is in the syllabus, it is in the NCERT also. That is middle row anomaly. What is middle row anomaly? So please, you can even write this with me. Yes, you're saying something?
It is in the middle row.
Arey bhai, can you speak properly?
Nothing, sir.
Okay. This middle row anomaly. This middle row anomaly, it refers to the relative instability of oxides of bromine. Relative instability of oxides of bromine. Now, in bromine, we have d orbital, d subshell or not? Do we have d subshell in? Do we have d subshell in bromine?
Yes, sir.
Okay. Now that d subshell, it will be completely filled. It will have 10 electrons, right? So
Yes,
all
sir.
10 electrons present in the 3D subshell are close to nucleus due to poor shielding effect. Due to poor shielding effect. Now, due to this, Z effective increases and force of attraction. And the force of attraction will also increase. Hence, what happens? Now, the bonds that are made between the oxygen atoms and the bromine, they are, see the force of attraction is higher between the nucleus of bromine, and the valence electron of bromine. Okay, so if the nucleus is attracting the electron in higher electronegativity and higher power, higher magnitude, this electron will not be available for oxygen for bonding, and that is why what happens, the bond between oxygen and bromine, it is weaker. Hence, bond between bromine and oxygen is easy to break. This easy to break. Okay, please write this.
Yes, sir.
Yes, what about others? Yes, what about others?
1 second, sir.
Okay.
Done, sir.
Done, everyone? Is everyone done? Please listen here now again. Now, say we understand that bromine will be less stable, but what are the reasons for more stability of iodine, the oxides of iodine and the oxides of chlorine? So write 2 more points. Oxides, iodine is larger in size, and hence more polarizable. That means oxygen can easily pull electrons from iodine because of its larger size. Okay, iodine is less electronegative, and that is why oxygen can pull more electrons from the iodine, and it can easily form bond, and those bonds will be more stable. So hence more polarizable, which makes stable iodine oxygen bonds. Next point, that is the chlorine. Now chlorine has d subshell, but those d subshells are vacant, right? Those d subshells are vacant.
Yes, sir.
Yes. Chlorine makes stable oxides due to the multiple bond formation and availability of d subshell. Because of the availability of d subshell. Now bromine lacks both of these, right? Bromine lacks both features. Neither bromine is as large as iodine to make it more polarizable, neither does bromine has vacant d subshell. It has complete fully filled d subshells of 10 electrons. Okay, so write these 3 points.
Yes, sir.
Now order of oxidizing power of different halogen. So if we find the oxidizing power, so it will be Br will be the most reactive. Then you will have chlorine. Then you will have iodine. Because the iodine is more polarizable, and the bond between iodine and oxygen, it is more covalent in nature. It is more covalent in nature due to the polarizability of iodine. Now your halogens is also done. We will look at some important compounds of group 17. Some important compounds of group 17. So the first one is chlorine gas, that is Cl2. Okay, chlorine Cl2. The first thing that we look here is the method of preparation. Okay, so what this is method of preparation. Now in method of preparation, you have again a name preparation. We have seen what we have seen for HNO3, Ostwald. We have seen Haber process for what? Ammonia. We
Ammonia.
have seen contact process for what? Yes, we have seen three, na? Ostwald. We have seen Haber, and we have also seen contact. Now contact was for which element, which compound? Ostwald for was?
Sulfuric acid.
Yes, correct. HNO3. Then we had looked with ammonia. Ammonia was for, sorry, ammonia. Haber was for ammonia. NS3. And after Haber, you had contact. Contact was for H2SO4. Now see, this is also important because this name reactions, this name preparation, they will give you, they can give you and match the following. Okay, and then they can give you the options. So in that case, you have to remember these processes. Method of preparation, you have Bacon's process. First method of preparation is Bacon's process. Now, this prepared by, please write with me, prepared by oxidation of HCl in the presence of catalyst cupric chloride. Okay, so you have HCl. The reaction is very simple. HCl plus Cl, sorry, you have HCl, then oxidation, that is O2. You will have CuCl2, cupric chloride, an elevated temperature of 725 Kelvin approximately. You will get HCl plus you will get Cl2. You will get HCl plus you will get Cl2. Copy this. Okay, wait a second. You can have some other process also. Write those preparation methods also. Second one, MnO2. The most important is Decan's one, okay? Plus HCl. You will get MnCl2 plus Cl2 plus H2O. We'll look at balancing later. Third, MnOH plus NaCl plus sulfuric acid H2SO4. You will get again MnCl2 plus you will get Cl2 and H2O. And you will also get, since NaCl is present, so NaHSO4. Fourth one, KMnO4 plus HCl. You will get again MnCl2 plus you will get Cl2 plus you will get H2O and KCl. MnO2 HCl MnCl2 Cl2 H2O. Done? Done. Are you guys done?
No, sir.
Yeah, okay, fine. इसको नहीं हो पाएगा लगता है. Chlorine is big.
Yes, sir.
Okay.
Done, sir.
Done, everyone? Is someone still writing? Okay, everyone is done. Properties. So in properties, you can write pungent smell. Right, it has pungent smell. Okay, it is suffocating also, or suffocating odor. Pungent smell or suffocating odor. Then you can see that forms chlorides with many metals and non-metals. Okay. So for example, if you have sulfur in S8 form plus you react this with Cl2, you will get S2Cl2. Get S2Cl2. Okay. So not 4 times because it is 8, and then you have to put 4 here also for Cl2. Okay. Second point is that it has affinity towards hydrogen. It has affinity towards hydrogen. So if you put something like H2S gas plus Cl2, then it will abstract the hydrogen and it will make what? HCl plus sulfur. So 2 hydrogens here, 2 here, and it is balanced now. Okay. If you have H2S or something like this, then it will abstract hydrogen. And for example, if you have some hydrocarbon H10, C10H16 plus Cl2, this will give you what? 16 HCl plus carbon. 16 HCl plus carbon. Okay. Next is reaction with ammonia. Reaction with ammonia. So you will get 2 type of reaction. If you have, for example, if you have NH3 plus Cl2 is in excess, then you will form product in which you will have HCl, obviously, because it is what? Has affinity towards hydrogen, and you will get NCl3. Okay, you will get NCl3. Third point, if you have NH3 in excess plus Cl2, then what will happen? See, initially it will form HCl. Now, I mean, after HCl is formed, you will again have NH3. So what is the reaction between HCl plus NH3? What do you get? You get NH4Cl, right? Ammonium chloride, NH4Cl. You'll get the same product, that is NH4Cl, plus you will also get nitrogen gas, N2, plus you will get nitrogen gas, N2. Okay, write this fast. Then we will look at the reactions with
Yes.
NaOH. Done?
So can you take previous page?
Previous slide. Okay, fine. Previous slide.
More previous.
More previous. Just wait a second. One more. Yes. More?
Sure. No front. Method of preparation of that chlorine.
The
Cl.
preparation is here now.
Yes, okay. Catalyst of what's prepared by oxidation of HCl
What?
in presence of catalyst. So prepared by oxidation of HCl in the presence of catalyst. What is that?
Cupric chloride. Cupric chloride. Cupric chloride.
Yes,
Also,
sir.
please, okay, wait a second. You can, I mean, HCl से हमने HCl ही बना दिया. This will be H2O. I made HCl and HCl here also. It will be H2O here. And Cl2. Please correct this down.
Yes, sir.
Cupric chloride. Write this. Raise it.
Yes, sir.
Okay, Sania and Amalia are done. Waiting for Abir, Fatima, Mariam, and Nazira. Okay, everyone is done. Thank you, thank you, thank you. Fast. Now we are just done with reaction with ammonia. Okay, fine. Reaction of NaOH, and there are again two reaction with NaOH also. You have either, if you will have NaOH which is cold and dilute, or you can have NaOH which is hot and concentrated. Okay, so reaction with sodium hydroxide. Reaction with sodium hydroxide. For example, if you have what, Cl2 plus NaOH, or this NaOH is cold and dilute, is what it is, cold and dilute. Then you will make products like write the product NaCl plus NaClO plus H2O. NaClO plus H2O. Okay, this product is there, and if you have Cl2 plus NaOH, you have hot and concentrated. If you have hot and concentrated, then you will get the product as since NaOH is more, you will get NaClO3. NaClO3 plus again you will get H2O. So if NaOH is more, you will get O3. If NaOH is less, you will get NaClO. Okay, that is the only difference here. Hot and concentrated, NaClO3, cold and dilute NaClO. The next point, chlorine, reacts with dry slaked lime, then it forms bleaching powder. Then it forms bleaching powder. You have Cl2 plus CaOH whole twice, calcium hydroxide, which is also known as slaked lime. Then you get the products as CaCl2 plus Ca OCl whole twice plus H2O. Okay, OCl whole twice plus H2O. Now this product here, this is the bleaching powder. You must have seen this in this way. You have, see, if you find this formula in the empirical form, it will be Ca whole twice. Then what do we have? You have Cl. How much? 4Cl. And then you have how many oxygen? You have O2. Now if you take things common, you will get Ca OCl2. Okay, so you must have, this is, you must have learned that this is the bleaching powder, but originally this is the bleaching powder. Okay, and this is the molecular formula. They have eliminated the ratios here. This is bleaching powder. Done? Done? Everyone
Yes.
done?
Yes, sir.
Is someone writing? No? No one is
No,
writing?
They're done.
Okay. Are Ahmad, I mean, you will answer for everyone or what? Right, the last one, this is the
sir, you
oxidizing.
are expecting a response and they are not responding. So
Oxidizing nature. Oxidizing nature. So if you have Cl2 plus H2O, it will oxidize what? Oxygen or hydrogen?
hydrogen.
Oxidizing nature. You will get
Hydrogen.
HCl, plus HCl. You get HClO plus you will get HCl. See, since here oxygen has, what is the charge here? Oxygen -2. If you see here, it has what charge?
0.
Not 0. See next, Cl2. It is not chlorine. I2 plus H2O. You will get HCl plus HiO3. Okay. So in here you had what? Iodine in 0 oxidation state, and here you had iodine. What is the oxidation state here?
+5.
+5. Next, Cl2 plus SO2 plus add some water. You will get, see, HCl is all common here. See, here also HCl, here also HCl, here also you will get HCl. Okay. Plus you will get H2 SO4. Next, Cl2 plus FeSO4 plus H2O. You will get HCl plus Fe2 whole twice. Okay, this is SO4 whole twice. Okay. Next you have, for example, Cl2 plus Na2SO3. This is sulfite. H2O. This will be getting HCl is common, plus you will get Na2SO4, plus you will get Na2SO4. Okay, this is the oxidizing power of chlorine. Done. So see,
No, sir.
at least
Just
one okay. One product, please remember HCl. Whenever
Yes,
you will
sir.
have the oxidizing power of any reagent, for example, even in HNO3, we said that before Pb it will be and if it is concentrated, it will be NO2. If not, then it will be either N2O or NO, right? So some of the products will be similar in all of the oxidizing agents. See here in chlorine, if you are oxidizing, you are getting HCl in each of the cases. Yeah.
Done, sir.
Done. Okay. Do one thing. Write the uses. Oh, the problem is that I cannot leave anything for you guys. Number one, bleaching agent. We have seen that chlorine and
Why,
oxygen.
sir?
I mean, I cannot say na ki I leave some blank spaces, write uses from the book, right? Because half of you will write and half of you will not write. Preparation of dyes,
No, sir.
organic compounds. Okay. Now in organic compound, most of the polyhalogen compounds such as CHCl3. What is this? This is chloroform. Then you have what? CCl4. This is carbon tetrachloromethane. Yeah, this is tetrachloromethane, and this is used as solvent. You also have DDT. That is also from chlorine. Second, third, for the preparation of poisonous gas. A is phosgene. B is mustard gas. Abir Haber was responsible for mustard gas, I guess, right?
Maybe, sir.
Yes, you won't remember. Tear gas. So also write the structure here. For phosgene, it is CO, Cl2. For mustard gas, it is Cl, CH2, CH2. Here you have sulfur. Here you have CH2. Here you have CH2, and here you have Cl. Okay. Now, for tear gas, it is CCl3, NO3. So you have NO3, NO2. This tear gas. Done?
Yes, sir.
Everyone done?
No, sir.
Sir, can you show the previous slide?
Okay.
Then previous. Yeah.
What we did? Yes.
Okay, sir, done.
Done, sir.
Done. Okay, fine. Now please listen carefully. Concept of aqua regia. Okay, aqua regia. Have you heard about this aqua regia?
No, sir.
No. You
Yes,
haven't
sir.
heard aqua regia. You have heard
Somewhere.
aqua regia. Okay, fine. It dissolves anything, na? If you add anything, it will dissolve it. Okay, so what is aqua regia? Please listen. If you should have 3 parts of concentrated HCl, is made by is a mixture of 3 parts of concentrated HCl and 1 part of concentrated HNO3. Okay, it is a mixture of 3 parts of concentrated HCl and it is 1 part of concentrated HNO3. The most important use of this is mostly used for dissolving of noble metals. What are the noble metals? We have seen, na?
Gold
If we
and
have H,
Helium,
gold and
neon,
platinum.
argon.
bhai sir, helium, your
Gold and
noble metal. I am
platinum.
saying he's telling me noble gases.
Okay, sir.
AU and
Gold,
Gold and
silver.
platinum.
No, only gold and platinum. Okay, gold and platinum. These are what? Noble metals. and they don't dissolve. Since you have seen, if you add Au plus HCl concentrated, there will be no reaction. Okay, if you have Pt plus HCl concentrated, no reaction. Au plus conc HNO3, you will again get no reaction. Either you add platinum plus conc HNO3, you will get no reaction. That is why what do we do? To dissolve these things, we use aqua regia. To dissolve these things, what do we use? Aqua regia. Now please remember these 2 points. The number 1 point is, if you have gold and you dissolve this in aqua regia, if you add gold in aqua regia, you will get AuCl4 negative. AuCl4 negative. You don't have to remember anything else. Okay, you don't have to remember anything else. If you have what? Gold, and if you add aqua regia, you will get AuCl4 negative. Second point, if you have platinum and you add platinum in aqua regia, what will you get? You will get Pt Cl6 2 negative. Okay, just remember these 2 terms here, and then we can write the reactions. Okay, yes everyone, can you tell me what do we get if I add gold to aqua regia?
AuCl4 negative.
Yes, and what do we get if I add platinum in aqua regia?
PTCl6 2 negative.
PTCl6 2 negative. Okay, now see, you will not be given reactions like this. You will be given reactions in a complex way, and they will ask you what will happen if I add gold in a solution. Then they will give you reaction like this: NO3 negative plus Cl negative. Okay, and they will say what will be the product. See, as you can see, this NO3 negative will come from where? HNO3. The Cl negative will come from where? HCl. So from this you will identify that this is what? Aqua regia. From this you will identify that this is what? Aqua regia. Okay, now you can easily make up the product. This will be AuCl4 negative, 4 negative. Okay, plus you will get NO, plus you will get nitrogen oxide. Now here you can say that what is the cold oxidation state? Here it is 0. Here it is, what is the oxidation state here?
+4.
X minus 4 is equal to -1. X is equal to 4 minus 1. X is equal to +3. Very good. This is +3. Okay. So here Au was the N factor. Here is 3. What is the N factor for nitrogen? Nitrogen here it is this form plus
+5.
5.
Yes,
Correct.
sir.
Here it is +2. Okay.
Yes,
So the N factor here is also what? 3. Since we have done this now, if we have similar type of N factor, we can take the common factor 3. So you can write 1, and here also you can write what? 1. Okay, since it is same, so you can write 1. Is that fine with everyone?
yes, sir.
Now you
Yes,
can
sir.
see here. Now here you have how many Cl? 4 Cl negative. So write 4 Cl negative here. Okay. Now you have how many oxygens? 3 oxygens here. Correct? You have 3 oxygens
Yes.
here. What you will add? You will add water. How many water should I add? 1 molecule of water, 2 molecules of water.
2 molecules of water.
2 molecules of water. Okay. Now since you have added 2 molecules of water, how many molecules of H plus will be added here? 4 H positive. Because we have to balance hydrogen also now. So 4 H positive.
Sir,
Now
but
it is balanced.
sir, I guess
Me?
only 1 molecule. Yeah, correct.
1 molecule of water.
Yeah, no, 2. Correct.
Because here we have 3 oxygens, here we have 1 oxygen. There is a difference of 2 oxygens, so that is why 2 molecules of water. Okay. Now please listen. Don't write. Listen. The N factor here was 1. Now comes the reaction of platinum. Here, platinum plus again you will be given. Okay, see this platinum and plus this is looking same thing. Platinum plus NO3 negative plus Cl negative, and here you will get what? PTCl6 2 negative plus NO. Now we have to balance. Now here platinum is at 0, so N factor will be, and here platinum is at what state?
+4.
Plus 4. So the N factor will be 4. So nitrogen here was in which state? It was in +5. Here it was in +2. So the N factor will be equal to 3. So you'll write 3 here, 4 here. Okay, now since we have 4 NO3, we'll have to put what? 4 NOs2, correct?
Yes, sir.
Since we have 3 platinum, so we should have 3 PT here also. Now how many chlorines will be there? 18 chlorines will be there, Cl negative, because 6 3s are 18. Right? Now what is the difference? How many water molecules do we need? Let us see oxygen. 4 3s are 12 oxygen. Here we have 4 oxygens. That
Yes.
gives a remaining of 8 oxygen molecules. That is why 8 H2O plus 16 H plus.
Yes.
You will have on Sunday only. I mean, this is done now. Group 18. You can start group 18 now. Write this fast.
Yes, sir.
Done? What about
Yes, sir.
others? Done. Okay. Now write the topic.
No, sir, not done.
ओके 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 भाई आप अपना माइक ऑन करके रखिए नहीं हुआ रहता तो as soon as I ask are you done please say no sir not done don't turn your mic off when you are writing Allah Akbar. Group 18 will be done and then only biomolecules. Biomolecules, inshallah, in 2 hours, I will send you some notes. You can see even in your NCERT, it is very small chapter. Not very small. Although I can also prepare slides if I want to, because it is a very small chapter.
Done, sir.
Biomolecules, little. In next class, I mean, I guess 1 hour class should be there for group 18, right? Group 18. Okay, so in group 18, what do we have? We have helium, we have neon, argon, krypton,
Xenon,
radon,
radon,
radon, and your favorite? Yes, Abhi, what is the last one?
OG.
Yeah, again a song. But OG, you know what? If you see the NCERT, na, you will see the in NCERT they have told you about the organoson. What is the half-life of organoson? It is 0.7 millisecond. Okay, so approximately in 1 second, whatever organoson you have prepared, it is completely vanished. So all of these, it is just predicted chemistry of organoson. We don't have the exact chemistry for organoson. Okay, the experimental chemistry is not present for organoson. Even for radon, that matter, it is also radioactive. So helium, what is the atomic number of helium?
2.
10. After this,
18,
18.
18. Then
36.
10.
54. 86.
486,
54. 86. And after this is 118. Okay. So now please start writing the. Okay, let me. Okay, now you will be confused how to write the electronic configuration. So this will be 1s2.
no, sir.
Okay. So here this will be helium 2s2 2p6. This will be neon 3s2 3p6. Krypton. This will be argon 4s2 3d10 4p6. Then you will have xenon. For xenon, you will add krypton 5s2, 4d10, 5p6. For radon, this will be xenon 6s, 2, 4f14, 5d10, and 6p6. Don't remember for obvious one. You want to write, then you can write it. Rn. Then you will have what? You will have 7s2. Then after 7s2, you will have 5f14. Then you will have 6d10. After 6d10, you will have 7p6. These two are radioactive. Okay. What are non-metal? All are non-metal. Done, everyone? So these are all are non-metal, all are gases also. Noble gases. The name only suggests noble gases. Done, done, done. Okay, group 18 is known as noble gases. Done, everyone? No? Yes? Anything? Nothing? Nothing.
Yes.
Yes, sir.
Okay. Now, again, we have a drill. We will start with what?
So can you take the previous page?
Slide. Okay, fine. Previous slide.
Okay. Yes, sir. Done. Yes, sir. Done.
Atomic size. What will happen to atomic size?
It will increase.
Top to bottom, it increases, right?
Yes, sir.
Top to bottom, size increases. So, helium, neon, argon, krypton, xenon, radon, oganosol. Okay. Atomic size. After atomic size, ionization enthalpy. Okay, ionization enthalpy. So ionization enthalpy will be top to bottom, it decreases, right? If we go top to bottom, the ionization energy decreases as ionization energy is inversely proportional to size of atom. So ionization energy will be highest for helium, neon, argon, krypton, xenon, radon. Yeah. Now after ionization enthalpy, write the melting points and boiling points. Okay. Melting point and boiling point, what happens? Melting and boiling points, so first write a note. See, the melting points and boiling points of noble gases will be very why it will be low, because as you know that these are first of all gases, and if they are gas, there are the only intermolecular force of attraction are the dispersion forces. Okay, so these are not strong force, that is why all of them has very low melting and boiling points. Noble gases have low melting points and boiling points as the intermolecular force of attraction, are London dispersion force, which are weak interaction. But if we compare, then we can say that helium will have the lowest, because as we know, if we don't have anything, then melting point and boiling points, they directly depend on what? Molecular weight. So if the molecular weight is high, the melting and boiling point will be also high. So helium, then you will have neon, then argon, then krypton, then xenon, then radon. Okay, so this will be order because melting point and boiling point are directly proportional to molecular weight. Since there is no concept of packing, no concept of hydrogen bonding, no concept of polarity, these are individual atoms and gaseous states, and so you will have it only dependent on molecular weight. Then yes, no, somebody please say something. Done?
Yes, sir.
Yes.
Yes, sir.
Okay. Now please listen electron gain enthalpy. Okay, please listen electron gain enthalpy. See, we have said that electron gain enthalpy, the first electron gain enthalpy is generally negative for, it is always usually generally negative. Okay, it is usually generally negative. But in noble gas, what happens? See, since noble gas, they have stable electronic configuration, right? All of them have what? NS2, NP6. So this is a stable electronic configuration, and they don't have any tendency to accept any new electron. They don't have any tendency to accept new electrons, right? That is why they have positive electron gain enthalpy, right? Since noble gases have stable electronic configuration, they have stable electronic configuration, they have no tendency to accept electrons. Since they don't have any tendency to accept electron, what will happen? Hence they have large positive values of electron gain enthalpy. Okay, large positive values of electron gain enthalpy. Okay, so now chemical properties are remaining. We will learn chemical properties in the next class, and it is not much. See, I mean, xenon is the only one which makes the compound, and there is a bit of history. How did we know? I mean, initially they would have all expected that these don't form any molecules. So how did we know, or how did we discover reactivity of xenon? So there is a bit of story there, and questions comes from there also. Now, after the xenons, we found that it is reactive and it can react. It forms, I mean, compounds with fluorine and oxygen. So xenon fluorine compounds and xenon oxygen compounds. Okay, so these are the only two types of compounds that we have to make, and we have to study about these things. Then we have also to study about some uses. Okay, so it would hardly take some 30 to 40 minutes. So in Saturday this will be complete, and also on Saturday I will bring some questions. Okay, okay guys.
Yes, sir.
Yes, sir.
Did you get the PDF?